So we're going to take a look at the 2008 multiple choice calculator section, beginning with question number 76. So in number 76, we can see that we have been given the graph of f prime, and they tell us in the prompt that f prime is the derivative of f original from -2 to 5, and we want to know the intervals when f original is increasing, so we're looking for when f prime is greater than 0 or f prime is positive. So this is the graph of f prime, and so f prime is positive, 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 and then after 3, f prime goes negative. So f prime is positive from -2 to 3, which is letter B, and that was certainly not a calculator question. In number 76, we are given the graph above shows the graph of f original. It is a piecewise function made up of two line segments from 0 to 4. Which of the following statements is true? So remember, we're looking for a true statement. So the first statement says the limit as x approaches 2 from the left-hand side does exist. So here's 2, and if we come from the left-hand side, this is coming from the left, we are approaching a y value, so the limit does exist. So that is a true statement. In number 2, the limit as x approaches 2 coming in from the right-hand side, so that would be coming from this way, from the right side, and we are approaching a specific y value, so that is also true. And number 3, the limit as x approaches 2 overall, so this is the overall limit, and since but these two limits do not agree. So the left limit exists and the right limit exists, but the left and right limits do not agree. Therefore, the limit overall does not exist. That's a false statement. So we're looking at C, 1 and 2 are true. In number 78, the first derivative of a function is defined by, so this is the first derivative, and we're looking for the intervals on which f is increasing, so we're looking for f prime to be positive. So I'm going to bring up my calculator, and I'm going to let the calculator do the work for me. So y equal to, I've got to turn the calculator on, and let's get rid of all of the stuff that's in there. So I have the sine of, make sure your calculator's in radian mode, always radian mode for calculus, x cubed minus x, close the parentheses, we're from 0 to 2, so I'm going to start with a, notice what I'm going to do, I'm going to press zoom 7 and then I'm going to press the off button to stop the graphing. I'm going to go to the window and I'm going to change from 0 to 2, and instead of counting by 1.57 I'm going to count by 0.1, so that's going to spread out my horizontal axis, and we're looking for where f prime is positive. So I'm going to hit graph and see what happens, and that gives me a nice graph. I'm going to put y equals 0 in as y2, second quit. I'll go back to the graph, and I can see from my calculator that the graph is, f is increasing when f prime is positive, which is this region right here. So I'm going to do a second calc 5. Oops, I did not do that. I said I was going to. Second calc 5. Enter, enter, enter. Enter one more time. And I get an x value of, oh, maybe I already did it and I wasn't paying attention. 5. I think I did. Enter, enter, enter. Yeah. So we start at 1, and that means that we're choosing between A and B. So I need that other point of intersection. So I'm going to do it again. Second calc 5. I'm going to move the cursor closer to the other point of intersection. Just has to be closer to that one. Doesn't have to be on top. Enter, enter, enter. And I get 1.691, which it tells me I'm looking at letter B. All right, so let's get rid of that. For the next time we need the calculator, second quit, and let's go back to the screen. Number 79. If the net accumulated area from -2 to 5 of f of x, so I like to draw my graph. This would be my f of x. And I don't know why I'm using I don't have to use my mouse because I have a tablet in front of me. So let me grab my pen. So I'm going to create a number line, and from -5 to 2, I'm just randomly sticking these on here, I have a net accumulated area of -17 from here to here. And then the net accumulated area from 5 to 2, so here's 5 over here. Now, notice that this is going in reverse. The net accumulated area from 5 to 2 is -4. Therefore, the accumulated area from 2 to 5 is +4. All right, so I am considering that I am moving from left to right. -5 to -2 was in the proper direction, so I had my -17. And then I reverse my sign from 2 to 5 to get a +4. So they're asking me the net accumulated area from -5 to 5, so that's going to be the -17 plus 4, which is going to give me -13, which is letter B. Number 80. The derivative of the function f is given. So again, we are given the derivative function. How many, all we have to do is count, points of inflection do we have? So I have two choices here. I can use the first derivative function to get this information, or the second derivative function to get points of inflection. If I'm going to use the first derivative, which I am looking for f prime of x. I'm looking for the local, or counting the local max and mins to determine the points of inflection on f original. I could make the calculator come up with the second derivative graph for me, but I'm not going to. So first derivative is x squared times the cosine of x squared from -2 to 2. So I'm going to go back to my window, -2 to 2. I'll leave it at tenths. I think that's going to be fine. We'll see what happens. We're going to count the local maxes and mins. And so I see one local min, that's 1, a local max 2, a local min 3, a local max 4, a local min 5. And so that is the answer. There are 5 points of inflection on f original because f prime has 5 either local max or local mins. 81 says g is an antiderivative for f, meaning that if we find the antiderivative of f of x dx, we get g of x. They're giving me an initial condition of 2, x is 2, -7, and they want me to find g of 4. So this is just an initial condition problem that says begin with the amount of area that you've already accumulated, which is -7, which we see here. And then we're going to accumulate the area from starting at 2, stopping at 4, which is E. Basic problem, net accumulation. 82, a particle moves along a straight line with the velocity given. So we have our velocity function here. It's only valid for t is greater than or equal to 0, and we're looking for the acceleration of the particle. So I'm going to go to my calculator, and I'm going to have my calculator to do the work for me. I'm going to do this on the home screen. I don't need a graph to do that. So there's the home screen, and I'm going to make the calculator find the derivative. So math number 8, find the derivative of my function 7 minus 1.01 raised to the negative x square in terms of x at the specific value of 3. And your calculator may type differently. This is an older model calculator, but I think the newer models are more evident how to type it in. If you're not sure, you can look in your resource packet because I have all the ways to use all the various calculator keystrokes to do everything. So enter, and we get 0.005. Whoops, let's bring the calculator back. 0.005 when you round that off. Okay, moving on to number 83. In number 83, we want area enclosed by these two curves. Now, area between two curves is not on the 2020 test, but we're still going to do this problem anyway because students in the future Hopefully we'll need this once we get back to a normal, whatever the normal turns out to be. All right, enough philosophy. All right, so we have x cubed minus 8x squared plus 18x minus 5. And then the second function is x plus 5. I'm going to do a Zoom 6 window to see what this looks like. I should be looking for a cubic and a line intersecting each other. And notice that I have a region of area here. I can box that up, so I'll practice my zoom box just to show you. I don't necessarily need to do that. So I'm gonna box up starting about there. So that's the bottom of my box. I'm gonna use my arrow to the right to capture how much I need of that. Then I'm going to use my up arrow to go above. And that's just going to blow that region up when I press enter. Just gives me a little bit better look. Again, I didn't really necessarily need to do that, but I just wanted to practice the zoom box. So we see two regions of area, so I need those points of intersection. So I'm going to do a second calc, number 5. And I like to put my points of intersection in order so that I don't mess myself up. So enter, enter, enter. Don't really need to store that, but I'm going to go ahead and store it. So second quit, store alpha A, enter. And then I'm going to find the second point of intersection, second calc number 5. And it has to be closer to that point of intersection. And that one is 2. Again, don't need to really store that. But I'm going to store alpha B, enter. And that last point of intersection, second calc 5. I'm going to jump on the line. Notice what I did there is I just used the arrow because it was faster to travel the line than it was to travel the curve. Enter, enter, enter. And it's 5. So I really didn't need to store any of those numbers because they were nice points of intersection. Alpha C, enter. So what I'm going to make the calculator do right now, I mean, not that on a multiple choice test I don't necessarily have to show my work, but on a free response section, which is what we're doing in the year 2020, you need to show your work on everything because you won't have any multiple choice. So we would accumulate the area from 1 to 2 of I already forgot what the graph looks like, which curve was on top. Graph. So in the first region, the cubic is on top, so I would have x cubed minus 8x squared plus 18x minus 5, because remember top minus bottom, x plus 5 dx, and then I would add to that the area from 2 to 5 of, now the line is on top in this, whoops, not y. The line is on top in the second region, so we would have x plus 5 minus, those parentheses are really important. Well, if you were going to do this by hand, x cubed minus 8x squared. They're important when you put them in the calculator too, 18x minus 5. But my functions are in y1 and y2, so I'm going to go back to my calculator, clear. I'm going to go to the home screen and clear that. Second quit. And so I'm going to do a math 9, which is integrate, and my first function is in y1, or the cubic is in y1. So I'm going to call y1 up over how my calculator does it, minus bars, or however your calculator calls up. If you have shortcuts, you should know what those are. In terms of x from, it's just as quick to type the 1 and the 2, 1 comma 2 plus another math 9, and that is going to be y2 minus y1 in terms of x from 2 to 5, close parenthesis, enter. Hopefully I did a good job of typing, and I did, and I get 11.833. Next problem is number 84, the graph of the derivative. So again, we have a derivative graph. So this is f prime. And the graph has horizontal tangents. That means slope equal 0. Horizontal tangent lines at x equal to -1, 1, and 3. Okay, so I can see that. Slope is 0, slope is 0, slope is 0. At which of the following values of x does f original have a relative maximum? So this is the graph of f prime. F has a relative maximum. This is all about me sheet. F has relative maximum when f prime changes from positive to negative. And this graph changes from negative to positive at -2. There's no change at 1. And changes from positive to negative at x equal to 4. So that's where the relative maximum would occur on f original. So this information about the horizontal tangents was just extraneous information that was trying to, I guess, lead me astray. In number 85, we have a table of values. It has information about f original and f prime. If f prime is continuous, so f prime is continuous, meaning that f is obviously differentiable and continuous. On the interval from -4 to -1, what is the value of the net area accumulated from -4 to -1 of f prime? Well, if we integrate f prime, we get f back. So where's f original evaluated from -4 to -1, which is f of the upper bound, -1, minus f of the upper bound, -4. F of -1 is -1.5, minus f of -4 is 0.75, and you can calculate that with your calculator to be -2.25. Number 86, we have another table of values, and this time we're looking at velocity of a particle moving along the x-axis. At t equals 0, the particle is at the origin. So the initial position of the particle is at 0. Which of the following could be the graph of the position function? All right, so the position at 0 is 0, so it cannot be letter D. It cannot be letter B, and I think there's also an E in here. So I've eliminated B and D just by the fact that the initial position was supposed to be at 0. At time 0, we were at 0. So now we're comparing A, C, and E. All right, let's go back and see what else they told us. We have specific values given. Now, something that's interesting to me is that the velocity at 3 is 0. So since I have a, let's see, we have selected values. So the velocity at 3 is 0. So when I come over here, 1, 2, 3, the slope here is not 0. The velocity there is not 0, so it can't be A. 1, 2, 3, the slope here at 3 is 0, so I'm going to keep it for now. 1, 2, 3, the slope here is 0. So now I've narrowed it to be between E and C. Now the difference between E and C is that the slope, from what I can see here, looks like the slope at 1 is 0, but in the table, the slope at 1 is a +2, which makes more sense right here, so I'm going to pick C as my answer. Number 87, an object is traveling along a straight line, so x of t is position. The initial position is 0. Oops, that's actually not correct. At time t, so at time 0, the particle is at 2, and this is the velocity of the object. What is the position of the particle at t equal to 3? Well, remember, position needs position, so I'm going to take the initial position of 2, add to it accumulated area starting at 0, stopping at 3, under v of t dt. The calculator's going to do the work for me. So my calculator, turn it on, clear the board. So 2 plus math 9 is integration of the function. I do fraction powers instead of cube root. You can do cube root if you want. 1 plus t squared, close parenthesis, raised to the parentheses, 1 divided by 3. So raised to the 1/3 power is cube root of, in terms of x, from 0 to 2, close parenthesis, enter. And we're looking at, that's not the answer that I got, 4.577. So what did I do wrong here? Cube root of 2 plus, it's 0 to 3. I did 0 to 2. So second answer, clear. Second enter will bring back the last argument. I went from 0 to 2 instead of 0 to 3. So be careful. Fortunately, the original answer I had was 4.577. There is a 4.512. Maybe I would have been tempted to go there, but I don't think so. I think I would have realized I'd made a mistake, and I just looked at the wrong number. All right, here we go. Your favorite, number 88, a related rate. The radius of a sphere is decreasing. So radius rate. So dr, get your pen, dr dt, decreasing, so negative, that's important, 2 centimeters per second. Read with your pencil. At the instant when the radius of the sphere is 3, so when r equal 3, what is the rate of change per second of the surface area? So we want surface area rate, ds for surface area, dt is equal to what? And they give me the formula for surface area. So I'm going to take the derivative of this function. So the derivative of s is ds dt implicitly. The derivative of 4 pi r squared by the power rule is 8 pi r, chain rule, dr dt, implicit differentiation. I know that r is 3 and dr dt is negative 2. So 8 times 3 is 24 times negative 2, and I haven't forgotten my pi, gives me negative 48 pi, which is C. Number 89, I have a function f original is continuous on a closed interval, and the two endpoints have the same y value. So I'm already starting to think about Rolle's theorem or the mean value theorem. If there is no value c between negative 2 and 2 where the derivative equals 0, which of the following statements must be true? Now let's think about this. For either Rolle's or the mean value theorem, we have the condition met that we have a function that is continuous on a closed interval. What did they never state? They never stated or indicated anywhere that I have a function that's differentiable on the open interval from negative 2 to 2. However, they're saying, and the endpoints have the same y value, so they said if the derivative is not 0, which is what they're saying right here, if the derivative is not 0, which of these statements has to be true? So it's going to have to be something that breaks the differentiability. So the first statement says between negative 2 and 2, there is a number where the first derivative is greater than 0. Well, I don't really know. Maybe the first derivative is always negative, so I don't really have a way of knowing that. B, between negative 2 and 2, the first derivative is less than 0. Well, maybe it's not. Maybe it's always positive. I don't have a way of knowing. From negative 2 to 2, there's a value of x. There's a value of x called k where the derivative does exist. Well, if the function has not met its differentiability criteria, then maybe the derivative doesn't exist. So I have to get rid of that. For negative 2 to 2, there is a value of x called k where the derivative exists, but f prime is not continuous. I don't know. Maybe f prime is continuous. Maybe it's not continuous. I don't know. For some value k, between negative 2 and 2, the derivative at k does not exist, and there it is right there. The differentiability, that's what breaks it. Somewhere there is no derivative, therefore, Rolle's or mean value theorem conditions are not met, therefore, we can't make the promise. So we're looking at E would have to be true in order for the theorem not to apply. All right, number 90. We have a function named f original. It is continuous on the closed interval from 2 to 4 and twice differentiable, meaning that there is a first and a second derivative on the open interval from 2 to 4. So we have some differentiability and continuity going on. If f prime of 3 is 2 and the second derivative is less than 0. Now, we have encountered questions like this before, and I don't want to say always, but almost always when we get that second derivative information, it's really not the concavity we think about. It's really about the preceding function. So if the second derivative is less than 0, f prime is decreasing. So that's what we want to focus on. Which of the following could be a table of values for f? So let's examine, well, I guess we can start with A and figure out why it is A, and then we can eliminate the other ones as well. All right, so if we find the slope from 5 to 2.5, 5 minus 2.5 is 2.5 divided by 3 minus 2, which is 1. So we get a slope of 2.5. And then 6.5 minus 0.5 gives me 1.5 over 1. And so if the slope at 3, if the derivative at 3 is 2, well, that makes sense because here's 3 right here. The slope of 3 at being 2 is somewhere between 2.5 and 1.5. We also notice that these values are these first derivative values are decreasing. All right, we can go on to the next one, and we can say that 5 minus 2.5 is 2.5, and 7 minus 5 is 2. And so that doesn't really give us, and it's really kind of like playing on the intermediate value theory. 2 is not between 2 and 2.5, but 2 is between 2.5 and 1.5. Even though this is a decrease, it doesn't meet the second criteria of f prime of 3 equaling to 2. So that's sort of an IVT thing going on with the first derivative data. The next one, 5 minus 3 is 2, and 6 minus 5 is 1.5. So the same thing, 2 is not between 2 and 1.5, even though the data is decreasing. The next one, 3 minus 5 is 2, 7 minus 5 is 2. Same thing, well, that's not decreasing, that's the same value. 5 minus 3.5 is 1.5. And 7.5 minus 5 is 2.5, which is increasing, so we have to get rid of that, and it has to be A. Number 91. So in 91, we're looking at average value of this function. So we're going to do 1 over b minus a. So that would be 1 over 3 minus negative 1, which is 1/4. The integral from negative 1 to 3 of cosine x over x squared plus x plus 2. The most important thing in this problem is to make sure that you put your denominator in parentheses when you use your calculator. So when I turn my calculator on, I'm going to clear my home screen. Instead of typing 1/4 with parentheses, I'm going to do 0.25. Math 9 is integration. The numerator is cosine of x, close that parenthesis, divided by parentheses, x squared plus x plus 2, close in terms of x from -1, comma, to 3, close, enter. And I get 0.813, which is the answer that you see here. And then lastly, number 92, a city located beside a river has a rectangular boundary. So we see the river over here, and there's a rectangular boundary to the city. The population density of the city at any point, population density, how many people can you cram into that space? At any point along a strip X miles from the river's edge. So we're moving in this direction, X miles. So that's in the X direction. Is F of X persons per square mile. So that's person per mile square. Which of the following expressions gives the population? We want the population of the city. Now, let's think about it. Common sense tells you that the population of the city would be measured in people or persons. So we're trying to look at these expressions, and the mile squared needs to go. So when we integrate or whatever we're going to do, we're going to have to get rid of those units. Well, if you look at letter A, if we accumulate area from 0 to 4 of f of x, and remember, we had persons per mile square. If we just integrate that, we will get persons per mile. We'll get rid of the square, but we still have the per mile, and we're looking for population measured in number of people or number of persons. In number 7, out front we have a 7 being multiplied, so that 7 is that's a measure in miles, so that would be miles. Integration of f of x is persons per mile square, and dx, notice that that's also measured in miles. So miles, miles, and mile squared divide out, leaving with persons, so we have letter B. 28, if you're wondering, well, why couldn't it be 28? Well, that's multiplying 4 miles times 7 miles. That gives me another mile squared, so the units won't undo each other. Why can't it be E? Well, they said it's X miles from the river's edge, so the X is changing. It was not set at 4, but the 7 was set because we're looking for a strip X miles from the river's edge. So if we're looking for a strip, then that strip would have to span the 7 miles, but it's X miles from the river's edge. And so that's why it has to be B.